Here we're talking about sine x, cosine of x, and bounded by this region. So the red is the cosine, the blue is the sine. So we're talking about this area right here. That right there is pi over 4. So we want to rotate that about y is equal to -1, which is right here. Okay. Alright, so 2, 3. Okay, so that line right there is going to be here if you rotate, and we're going to meet around, this is 1 over root 2. We know that that's where they meet, so about there, and like right there. Okay, so we're rotating the area like this. Okay, there's a hole in the middle. Okay, like that. Okay, so that's a little bit hard to see. Okay, so but this is what we have to do. We have to integrate from 0 to pi over 4. Pi, first of all, the outer radius. Okay, so the outer radius is a cosine, so it's higher. Right, so let me call that y1. Maybe I should pick a different color, orange. Okay, y1, and let me say the inner radius, or the smaller one, y2. So to find this volume, it's going to be this: pi y1 squared minus y2 squared. Okay. So y1, right? Y1 is the y value of the cosine, so it's going to be cosine of x. So it's cosine squared x minus y2 is a sine, so it's going to be sine squared x. Okay, so if you just evaluate that, we get the volume. The best way to do this is to recall that this right here, factor out the pi at the front, that right there is actually cosine of 2x. It's a double angle expansion of cosine of 2x. Okay, from there it's easy. Pi, so it's going to be sine 2x times by half. That's the antiderivative of cosine of 2x. Okay, 0 pi over 4. So pi over 2. Let's plug in pi over 4 in there, and we get sine of pi over 2. Right? And then plug in 0, you get 0. Sine pi over 2 is 1, so the whole volume is, right, pi over 2, of course, unit cubed.